Hi, I'm chairman of IDTechEx running this show. My name's Peter Harrop and I'm interviewing Intrinsiq, which is a company that's doing some very exciting work, and we're going to have them introduce themselves.
Okay. Good afternoon. I'm Robert Need. I'm the CEO of Intrinsic Materials, and we make nano copper-based inks and pastes. So what we do is we formulate inks and pastes for electronic applications. We place it on many different substrates. Where the business is today is that we're working with applications engineers, because although we make the ink and paste, we need to work with the total process of the application, dispensing, and the centering processes to put it not only on rigid FR4 type materials, but also flexible materials like polyimides. We can go down to 1 micron line width and spaces, which is very good for the integrated circuit arena. We also work in solar on glass. So if you think about the applications, our materials go on everything from fibers to solar to automotive and all the other different areas.
So with the printing of copper, it's had a slow start. Like all new technologies, it's been quite a long time with some difficulty with maybe 10 Japanese companies having different solutions, and some are physics and some are chemistry. You're physics, you do it with plasma, don't you? Yes. I wanted to ask you really, why was there a slow start in adoption of copper? Because we don't really want to cover the world with silver as a precious metal whenever we print.
Right, well that's a very good question. And the answer to that is that we have a proprietary process where we coat the individual copper nanoparticles, and that protects them from oxidation until they're put in the formulation and use. Matter of fact, they're protected all up until the point that they go through the reduction process in the final application. So that has given our material the advantage over the coppers that were used in the past. And I should say we do this with more than just copper material. We are a nano material producer, a copper producer
right.
of a lot of different conductive materials.
Oh, I didn't know you did other materials too. But when just dealing with copper to start with, we read about how it has an advantage over some other metals in that you don't get the sideways creep. Is that real?
It all depends on the formulation. One of the things that when I say that we're in the phase of the application engineering to help our end items is because the formulations have to be specific to the substrate. So when you talk about creep or weeping or anything that goes on the material surface, we formulate it for the specific wetting capability of the substrate. Now what copper does is it's more robust. When it goes through the centering process, the individual nanoparticles are melted together, so you get very good conductivity. We've done as well as 2 times the resistivity of bulk copper. Copper is in the bulk stage. Copper is 100 times cheaper than silver. In the process stage, our inks and pastes are as much as 50% cheaper than silver.
But in comparative terms, sometimes the performance is better in terms of resisting sideways creeping and so on.
Yeah, well, and also dissimilar metals. Yes. So when you place our materials in an application for a ball grid array, you're putting copper against copper in the circuit board.
Fine. So you haven't got any electrolytic action or whatever.
Correct.
So that's a huge advantage. So there are some problems obviously with copper can poison an OLED, and with dissimilar surfaces it could give you electrolytic action. But is your dream or your view, your long-term view, that a large amount of silver printing could be replaced with copper? Do you think there is considerable opportunity, or is this very much a niche of a niche?
No, there's a very, very large possibility that we're going to replace silver in some applications in volumes. Another area is copper foil that is used for copper cladding, rigid and polyimides or rigid and flex circuits. We do a additive process, which is what you see here, as opposed to a subtractive
much
process.
More elegant, absolutely.
So you place the ink down, you center what you want to keep, and then you wash away the rest, as opposed to what the industry does now. They start with a very thick layer of copper, and they etch it down to get to the thickness that they need. and then they take away the parts they don't need.
Yes, and I mean, although copper is a much lower price than silver, the price of copper is still an issue if you're going to waste a lot of it.
Well, it's also a green process.
Absolutely.
We pollute the world a lot less by adding
that's a good
what you
point.
need versus all the chemicals that you go through when you're doing a subtractive process.
Well, that's a good point. So what industry would mainly, in terms of, I mean, your strategy will evolve in the light of the world you live in and what you learn, but I mean, what's your latest view as to your biggest opportunity? What is the sweet spot? Is it automotive? Is it medical? Is it space science? What is it?
Well, it's right now it's emerging to be automotive. And that is probably, when I don't want to wear out the word emerging, but they're looking at applications that aren't necessarily we're replacing a similar item. So you could replace a wiring harness with a conductor on a fiber, for example. But whether it's in solar or displays to replace the silver that's in the bezel, some of the other heavy conductors, it's across the board. We're working in every area. We've got a dozen applications in evaluation right now with end item customers, and it is in existing and emerging markets.
So what type of solar is that? Flexible solar?
Well, it's also rigid, but so one of our materials is a nickel silicide, which is used to protect the silicon from the copper, so that we can put that down as a paste and use that as a contact.
Right.
Yeah.
Oh, how interesting. And you described it as being on polyimide, and this is an example. That presumably is something that's quite commonly used in automotive because of the temperature.
Right.
So what you offer in automotive will often be on polyimide, will it?
It could be. It could be on some other substrate. Right. So, like I said, where the business is right now is we make and we have on the market electrically conductive inks and pastes. Where we're working with customers right now is to make sure that they're comfortable with the process to get the best performance out of their product as received or as performed, and then the life that they need out of the product.
And your plasma process produces a variety of sizes of particle, but do you see that as can be an advantage?
Yes, because as you formulate for different applications, you need a different mix of nano and even micro particles to get the consistency that people want for different applications.
It's wonderful.
Yeah.
I wish I had your job. Very exciting.
Yeah.
Thank you very much,
Well,
Robert.
I appreciate
Wonderful.
the opportunity.
Tremendous company. Thank